So what is the relationship between layering of fluids and density? First, you have to know that fluids can be liquids or gases. The defining characteristics is that they could flow. Most materials in Earth's atmosphere are gases. Understanding the behavior of fluids allows us to understand the movement of air that results in various weather phenomena. Density is a fundamental property of all matter. Density is defined as the ratio of a mass to its volume. Water has density, the air in a balloon has density, the building stones in the Great Pyramids have density, an apple has density. Every substance has density. Because density is a property of all matter, it can be used to compare materials. But how do you compare the density of the ocean to the density of an apple? One must compare the masses of identical volumes of the two materials to see which is greater. The unit volume used to describe density in the metric system is cubic centimeters, cm to the third power, or milliliters. The unit of mass is the gram. The greater the mass of the cubic centimeter or milliliters, the greater its density. There are two elements of density: volume and mass. Volume is three-dimensional space. Mass is the substance, the presence, the real stuff of which matter is composed. Mass is directly related to the atoms in matter. Two characteristics of atoms determine the mass of a sample of matter: the number of atoms in the sample and the mass of each atom. Atoms can be close together or far apart. The more closely they are packed, the greater the mass of matter. The periodic table of elements is organized by atomic mass. Hydrogen and helium are examples of light atoms. Lead, gold, uranium are massive atoms. Mass is determined by weighing matter to find out how much force it exerts in Earth's gravitational field. We infer mass based on weight of a sample of matter. If all matter came packaged in convenient centimeter cubes, determining density would be simple. But matter comes in all shapes and sizes: bottles, nails, oceans, mountains, coins, atmosphere, and so on. To determine density, you have to determine the mass of a cubic centimeter or milliliter of the material and then compare it. If you have an apple, you could determine the mass using a scale. An apple might be 270 grams. Volume can be determined by submerging the apple in a container full of water and measuring the volume of water displaced by the apple. If the apple displaces 211 milliliters of water, it has a volume of 211 milliliters. If you know the mass and volume of an object, density can be calculated using the equation D equals m over v. Density is mass per volume. If you divide the mass of a sample by its volume, you know its density.